On the systems approach. Simply. Let's look at Figure 1. Any system is considered a set of interconnected elements, having an output, a goal or purpose, an input, resources, a connection with the external environment, information flow 5, and feedback loops. Feedback is the effect of the results of a process on its course. These are flows 1 and 2. And also 3 and 4. It seems simple. Let's consider how systems work in the universe, in living nature, in technical devices, and in society. Let's discuss Figure 2. Let's call nature with a capital N, the Big Bang and the laws of its development in the universe towards heat death. First, the Big Bang develops in the form of cooling streams of energy in the increasing volume of the universe. As it progresses, the thermodynamic state of the universe becomes more complex, its entropy increases. But this cannot happen instantly to the state of heat death throughout the entire volume of the universe due to inertia and the impossibility of energy and matter moving faster than the speed of light. This plays the role of feedback in the universe. It works automatically. Therefore, a simplified model, shown in Figure 2, can be applied to describe it. Currently, the most complex systems known to us are living beings. A living being is a set of physical and chemical processes occurring in an organism, allowing it to carry out metabolism and cell division, or reproduction in the most developed living beings. At the higher stages of animals, they, while reproducing, also strive to improve themselves in future generations. Figure 3 shows that to model a living system, which is more complex than the universe, a more advanced model than the one shown earlier in Figure 1 must be used. Unicellular organisms, receiving food and information from the outside, process it with their primitive organs to live as long as possible. Unicellular organisms study the external environment electrochemically via channel 5, searching for food and investigating dangers. Using primitive organs of movement, they move towards food and avoid dangers as best they can. Thus, feedback with the external environment and in managing their life activities is realized via communication channels 3 and 4 of the animal organism. In the most developed animals, and to the highest degree in humans, in addition to instincts and survival information at the lower level, a special apparatus, shown in Figure 4, is formed, responsible for working with information from the external environment. The carriers of information inside higher animals are now very subtle energy flows in the form of electrical signals. A higher animal collects, accumulates, processes, and uses information already in the form of knowledge for more successful survival and competition with other animals. Let's call this the System for Increasing Intellectual Potential, SIIP. For brevity, we will use the abbreviation SIIP. In animals, SIIP evolves very slowly. In a particular species of animal, us, a rapid progress in SIIP is obvious. Especially since the time humans created states. Recently, an avalanche-like rise in SIIP has been observed. People have created computer technology to enhance it. And now artificial intelligence. We will call it AI. As at the lower level, human SIIP has an information framework created based on the universal cybernetic model. Because this is dictated by the laws of nature. The information flows of SIIP in Figure 4 are colored red. A person explores the intellectual information offer of the external environment via channel 5. Depending on their needs, received via channels 1, SIIP opens useful flows for it via channel 2. Via channels 3 and 4, a person realizes their intellectual state and improves it for the main meaning of life, to live as well as possible and improve themselves in future generations. Thus, the two main feedback loops of SIIP work. Virtually all channels circulate multiple streams of information. A person uses sight, hearing, taste, smell, and touch in their SIIP. Scientists are studying a sixth, parapsychological, sense. It works in channel 5 of SIIP. In the future, this subconscious feeling will be used more actively. In simple terms, a person's SIIP is first nourished by parents. Then they enter the society's education system, starting with kindergarten. This continues in school, in higher education, in postgraduate studies, in doctoral studies, in regular professional development courses, seminars, scientific conferences, and exhibitions. A social person is constantly surrounded by a cultural environment. They visit cinemas, theaters, exhibitions, and interest clubs. A person receives a lot of new information while traveling within their own country, to neighboring and distant countries. There is no such thing as too much intellectual information. Particularly smart people constantly pump new information through their SIIP. Pay attention to the flow of new information at the output, in the sense of a person's life. This is the new information that a person invents and transmits to society. There is research showing that the costs of a person's SIIP are repaid many times over by the material goods they receive from society. Furthermore, it is known that the greater the volume of intellectual information a person pumps through themselves, the longer they live. But it is necessary not only to receive intellectual information but also to produce as much of one's own new information as possible, and give it to the external environment. Otherwise, the heat death of SIIP sets in and the physical life of a person ends faster. It is natural that teachers, scientists, and cultural figures have always lived longer than the average life expectancy was and is. We invent various mechanisms and devices to improve life, based on the laws of nature. Therefore, as in the structure of humans, in the technical systems we create, there is an input, an output, feedback loops, and a program set by engineers to work as long as possible. Feedback loops are set up to automatically maintain an equilibrium state and the operational capability of machines. In high school physics, we were introduced to Watt's regulator. In the first steam engines, it was the main feature of the system. The productivity and safety of the steam engine depended on it. Naturally, the first automobiles running on steam necessarily had Watt's regulators. Later, when internal combustion engines and jet engines were invented, automobiles, airplanes, and rockets also have regulators that, depending on the load and the assigned task, perform the feedback shown in Figure 1. Previously, this was done mechanically. Now, feedback is organized more accurately by electronic devices. Artificial intelligence is being connected to the control of modern complex machines. A fatal flaw in the control system of the Chernobyl nuclear power plant was the erroneously designed or improperly operated feedback devices of the ill-fated nuclear reactor. I was lucky in my diploma project to design an automated control system for a copy milling machine. This is a technically fairly simple machine. But it has a generator, an engine, a tachometer with nonlinear characteristics. Therefore, to determine the time delay of the feedback in the control system, it was necessary to calculate a differential equation using the operational method. I still remember that the delay in my project had to be 0.7 seconds. It is on technical devices in laboratories that one can see the action and experiment painlessly with feedback loops. The figure shows different scenarios for setting up different feedback loops, for example, in a copy milling machine. Optimal feedback, after starting the machine, will reach the optimal cutter speed in a minimum time and show the machine's maximum productivity. When the cutter encounters depressions or elevations, the control system will automatically reduce the cutter speed and increase it on easier sections. Weak feedback, too much feedback delay will not allow obtaining optimal productivity. The cutter and its feed will be slow. With too rigid feedback, the control system will jerk the cutter and its feed, which will soon lead to machine breakdown. Usually, in nature and real technical devices, negative feedback is set up for productivity and safety in production. Also in transport and energy systems. Sometimes, in special cases, which we will not touch upon in this simple presentation of the systems approach, positive feedback is set up. In the example of a copy milling machine, with positive feedback, an increase in load causes the regulator to increase the feed and speed of the cutter. It is easy to guess that this will soon lead to machine breakdown. For example, a nuclear explosion chain reaction has positive feedback. A person with rigid feedback in behavior is called choleric. A person with too soft feedback in behavior is called phlegmatic, and can also be melancholic. A sanguine person has optimal feedback with the external environment and themselves. Such people are most effective in their lives. When a person's body temperature regulation feedback deteriorates and becomes positive, they urgently need treatment. That is, to correct the feedback. The state is a set of economic, political, and spiritual relations of people with the purpose of arranging things so that members of society live as well as possible and improve themselves in future generations. First, this is achieved through labor cooperation and specialization. It is not hard to guess that the information model of society is much more complex than the model of an individual person. Nevertheless, society has a model built on the basis of the universal cybernetic model. It will be close to the information model of a person. Because people organize and manage work collectives, cities, and states in their own image and likeness. Such thoughts were inspired by my experience working as the mayor of a small town. I will now speak not scientifically but nostalgically and metaphorically. I imagined that the boiler house was the city's lungs, the power supply was the blood vessels, the treatment facilities were the liver. The city's economy and social sphere are the digestive organs, ensuring the comfortable life of the townspeople. The head is the city council. The state, like a city, has systems that reproduce human organs. In the state, the skeleton maintaining order is the political system. It is interesting that in society, with the use of computing technology and artificial intelligence, information flows, their collection, accumulation, and use are becoming more and more similar to what happens in the human body. Only the system of binary information encoding and computing is both simpler and more reliable than the quaternary information encoding, as happens in animals and humans. Therefore, we are more vulnerable to the effects of diseases. Although machines also get sick. And the causes are viruses. They are different from those that harm us. But in name and in essence, it is the same thing. In the state, commodity-money relations are established between input and output. They create economic tension between the poor and rich strata of society. The management of society, politics, also creates political tension proportional to the economic tension in society. The poor strata of society experience dissatisfaction due to the inability to obtain the education necessary for a better life for themselves and their children. Tensions in society were felt particularly strongly in the early stages of state development. This led to uprisings, revolutions, and wars. We will talk about this in the next clips. Like all thermodynamic systems, states strive for an equilibrium state. This is when goods are distributed equally among members of society. Then the political system is minimized. All members of society have free access to the knowledge and cultural values of society. But society will not be able to achieve an equilibrium state, communism, for a long time. Because with a still rather low general level of knowledge and culture, people find the stimulus to live as well as possible in connection with economic tension. The highest level of development we have achieved now is the information society. The closer a country is to this level, the less tension there is between societal strata. The level of a society's development is not difficult to determine. You need to look at the statistics of the citizen's life expectancy. The better, softer the economic, political, and spiritual relations in a state, the longer its citizens live. This very important conclusion follows from the previously shown facts about human longevity. The system for increasing intellectual potential, SIIP, of society is the main tool for transforming people's lives for the better. Improving SIIP should become the main task of society's leaders. Everything else, with a high level of intellect among citizens, improves automatically. The effectiveness of politicians, scientists, teachers, and cultural workers can be found in the information published on the internet about average life expectancy in different countries. Here we illustrate the lists of the most developed and lagging states. So, the state as a system of social relations, which we see in the model, is a more or less tense system with a tendency to degrade relations. In this case, one must understand that degradation is equality in the economy, a reduction in the strength of the political system, and the free circulation of information in society. This is exactly what is needed for a better life for people. Check the development level of your state. By participating in the system for increasing intellectual potential, you can most effectively improve the state of your society, your family, work collective, city, and state.